I'm glad we all agree that Bakersfield, California is the least cool city on the entire planet and that Unalaska is like way better. Cool. All right. So as we look at this, I want to use this function notation stuff and we're going to look at it, but we're going to dilate this down first. So first thing, if it is a scale factor of 1/2, and I may have accidentally given this away just in language that I used a moment ago, are we making it bigger or smaller? Smaller. And what's the real word for making this smaller? This is a reduction, and I'm cool with that. Now, whether you physically write these down or not, it does help if you're struggling to work it out. How do we know it's a reduction? It's smaller than 2? 1. I like that one, and I might have misheard you. Okay, so check it out. Sometimes these can be ugly. Sometimes they can be really nice. But I think that maybe with a little bit of tweaking, we can make them all really nice. So let's think this out. This, in my opinion, AB is the easiest segment to make. I can measure the distance from A to B. How far is that? From this point at -6, 5 to the point 0, 5, which is what B was. What's the distance between them? 5? Are you sure?
Oh, wait, no, 6.
Lily's changed to 6. Do you guys all agree? And if you're not sure, 1, 2, 3, 4, 5, 6. We have 6. And we're scaling it by how much? So on the new one, it's going to be half that length, and it's going to be somewhere along this green line, right? Okay, instead of going 6 units over, what's half of that? So I'm going to start at A, and I'm just going to count over. 1, 2, 3. This is my new image. What's the name of this point? A prime. And then we'll do it all in the graph, and we'll clean it up here. What did it become? What's this new ordered pair? So love the thought, but here's the issue. And I know exactly where the issue is. You're thinking about having it, right? But if we use the picture that we have, like, because we're not going about the origin, maybe stuff moves. Like, without just trying to reason it out and, like, plug it into some formula, this is -3. What's the y value? The x changed, but not the y in this situation. That's okay, because it's going to be somewhere along this line that we extend, like we saw yesterday, from our center to the vertex, and then we just mark out the length on it. So I'm okay with 3, 5. Now, this one's super nice. What made this so nice? The fact that AB was what sort of line was really convenient for us. If you don't have an answer for that one, you will here in a second. What point do we want to deal with next? C or D? Okay, deal. What's the, love this. What's the distance from A to C? Why can't anybody give me an immediate, fast answer? And you shouldn't be able to, just, I'm not faulting you. Like, that's what I'm expecting. I can't even tell you, because how do we find that distance if we want it? We're really going to lean into this weighting thing because people keep looking at me, and I think it's because people have an answer, but they don't want to share it. Carson, why is this not, do you have the distance yet? We could use a distance formula. We could use Pythagorean theorem, but those are kind of ugly. Like, you could use that. We could say this right triangle, if we wanted, we could make this happen and say, okay, well, what's the length of two sides? We could Pythagorean theorem, right? Do you want to do all of that? No. Maybe there's an easier way. A diagonal line is harder to work with than a horizontal or a vertical because there's a change in x and y, right? So let's see if we can't break this down just a little bit. If I know that it's half as long, there's a couple ways we can think about this. Every diagonal line has two components, is the way that we refer to them. Every ordered pair has a pair of stuff. What are the things that we put inside of our parentheses? This represents something, and this represents something else. X and Y. If I want this to be half as long, I could do the whole distance formula thing and make it blah, or check this out. How far from A to C do I go down? And I'll just draw this line right now. How far down, because that's from this y value to this y value, how much should we change? We went down 2. Does everybody agree? If I wanted to only go half that distance, I would go down how far? So I know that I'm going to go down 1 value. So wherever this is, what's the y value of my new point, C prime? And we're going to make this out because I can't tell if the silence is because nobody understands. Can we do a quick thumbs up check? Do you understand what I just said rather than me trying to judge your non-existent facial expressions? So check it out. Do you agree that to go from A to C, we go down 2? But we're scaling it by a factor of what? So let's just go down half as far. Instead of going down 2, we go down how far? So we'll go down 1 to our next point. And if we're at 5 and I go down 1, I will be at where? 4. That's all I was trying to get by. Half the distance in the vertical direction is 1. How about horizontally? How far do we run from A to C? 10. From -6 to 4 is 10. And we're dilating by a factor of what? So it's half the distance. 5. So if I start here, I now know that I need to go down 1 because that's half the change in y. And right how many? 5. So let's go down 1 and right 5. Does it happen to live right on that line that we extended? And what's this new name? This is C prime. And where does it live? -1, 4. We could use distance formula. We could do your stuff. Lily, did you get the same point? -1, 4?
Yeah, but for A prime, should it -3, 5 be not A?
Lily pointed something out. Anybody else notice that I did A and then I was going from this center to move B, right? Should this really be A prime? I took B and I went half the distance back. What should this point be called? This should be B prime. That is a typo. Did you notice it earlier, Lily, or just now? Okay, that's my bad. I should have noticed it. That's a typo on my part. Okay, I want you guys to do D prime for me real quick. I would use the same method that we did here instead of distance formula and stuff, but it's your call. I'm going to give you a second. Get me D prime. While you're doing that, I'm going to get my lovely mapping notation set up. And sorry, Drew, if you're watching the video to just watch me drawing stuff here, it's not very exciting. But I'm going to come and check. So only because, yes, but only because it just so happens that the central dilation is on the J. Like the only reason, if it were here, we would do the line like here. Okay, so like when you go from here to here, how far down? So half of that. So instead of going down 1, you would go down how far? 2. And then I'm like going over. So good. So you go down 1 over 2. Is this easier than doing it this way? Okay. Are you still struggling forward? Okay, so I'm going to help her do this one, okay? So because this is our center, to go from A to D, this drives me crazy. Is that what's happening? Okay. Is that lowercase a? Drives you crazy, Lily, but that's okay. So check it out. We're going to get the same point. To go from our center of dilation to D, how far down are we going? I see these are each one. So pair pressure, 1. Don't just go 2. And we're dialing by half, right? 2. So instead of going down 2, what's happening? Down 1. That's going to pause. How far horizontally can we travel? This is a weird one because this has 3. That's why I say we have to see. So if we're here, we'll go over 1, 2, 3, 4. So instead of going over 4, how far should we go? So it's going to be weird because this again. So here's 1, here's 2. It's exactly. All right. looking at these. Quick check. To go from our center of dilation, which just coincidentally happens to be at A. We are not just choosing A because it's our center of dilation. To go from our center here to D, you would go down 2, right? But what's half of that? 1. So I'm going to lose my graph paper here for a second, and that's okay. But I'm just going to physically do it. I'll go down 1. And then going right, we would normally go 3, 4. Just kidding. So what's half of 4 horizontally? So I'll go 2 over, and it just, maybe not at all by coincidence, just so you know, lands exactly on our graph. And it should be because it's the same line. So what's this ordered pair that we'll now call D prime? -4, 4. Now, if we look at this, there's one wonky thing that's happened. I'm going to really clearly shade this in. There's one point that we've yet to talk about. But if you look at the solid purple figure and we compare it to the new and improved or shaded in figure, is the big original one and this the same shape? Are they the same size? No, they've been dilated, but are they still similar? Are they the same shape, different size? So there is similarity here. Now, there's one thing waiting in the wings that we have yet to discuss, and this is the last little part of it. We'll get some notation, and I'm going to give you guys some time to practice with these to make sure we're cool with them. B moves after this lovely dilation to its image point, B prime, which we said was -3, 5. Where did C move to? Where's C prime, rather? Love it. -1, 4. How about D prime? Okay. Last question that Lily loved the comments, but Lily's not allowed to answer this one out loud. With your neighbors, where's A prime? Because that one's weird. Or if we don't have to talk it out, if we have an answer, somebody but Lily, I'm also cool with that. Carson, we're making a lot of eye contact. What? Why doesn't it move? Love it. A and A prime are the same because they are the same point, right? Or sorry, the center of dilation is on A. If I wanted to move this figure here, and this was my center, would it be at the same point anymore? No, but we could do the exact same thing. We could count how far do we go and then cut it in half. How far do we go and then cut it in half? And I'm just going through each of these vertices here to make that happen. We can always do it graphically like this. Now, Lily, would you like to share your approach? Okay, so I'm going to draw. Let me clear this out. I'm going to do some fancy stuff up here really quickly, and it's not going to be the same numbered point, but I just want to draw it. So we have roughly this shape, and it's not exact. Did our actual figure go like this? Okay, so here's our rough figure, and I know it's not perfect, and that's okay with me. Hopefully it's okay with you. Lily, walk me through your basic process.
First I translated it 6 to the right, 5 down.
So I'm going to pause on that real quick. Here's my center of dilation. Lily said what she did was not exactly what I had done, but instead she took this and she moved it 6 to the right and 5 down. By doing this, where did Lily move her center of dilation? So I'll go back up here. Where was our original center of dilation? So check it out. I'm going to write it here. That's our center, right? Okay, so we'll do the same thing. Lily said she used a vector and she went 6 to the right and 5 down. Where did she move the center of dilation to? And my graph is good except for this part. Like every other number is fine. Where is the center right now on this one? 0, 0. Give me another name for it. The origin. And then, Lily, if you'll continue, we now had all these points at the origin. How do you now scale it by a factor of 1/2?
And then I just scaled it by a factor of 1/2.
So like this point, and I'm okay with that, and we're going to make sense of this. This new point, and I should probably look at the real one to make sure I get the right point. If I move this 6 to the right, this is going to be at 6, 0. That's what this point becomes on Lily's. I moved it 6 right and 5 down. Here it is. How do we do the dilation if it's about the origin? Check your notes from yesterday. You just multiply both by k, right? What's 6 times k? So 3 and 0 times that. So Lily identified that her center, and this is not perfectly to scale, but it will be pretty close. It's actually way closer than I thought it was going to be. If we do that, this is now D prime. Is that true? B, thank you. Lily found B prime instead was at 3, 0. But she had initially moved it, right? If she now moved it back, and she did this with all the points, I'm just showing one. If we move this all back, and I'm going to leave off the showing B as 3, 0 part. So we'll just move it here. Let me reselect. Lily moved everything, and she did all these transformations, and then she moved it up 5 and 6 left to move it back. Where does B prime wind up? And I think I'm too high up here. Does it wind up at -3, 5? It's the same thing. Whether you want to move it with translations, if you're comfortable with the vector stuff. Remember Instagram's at Disneyland, how do we pose? Come on. Okay, so we got it, right? Like it's the Instagram brackets is why I'm bringing that up. It's vectors. Okay, now last little thing. Quick check. This problem, yay, nay. I need thumbs up says, yes, I'm really good. Thumbs down says, I don't know what's going on anywhere in between. Okay, we're going to do one more. We're not going to do a whole shape. It's weird. We're only going to do one part of a shape. We're going to dilate a single point. 1 point, that's it, which is, we're not really changing the size of a point because they don't have it. I'm just giving you 1 point from a larger figure. So here we go. We're not even going to have like perfect graphs, and we don't need perfect graphs. What's your favorite point on the coordinate plane, Vincent? Anything but the origin, and preferably not 1, 1. Something a little grosser than that. -6, 7. Okay, so here's our point at A, at -6, 7. Now, Carson, there's not a right or a wrong answer. What are we going to use our scale factor as? 1/2. Can I make it? I'm fine with 1/2. I'm okay with that. That's okay. 1/2. And then finally, the center of dilation. What would you like it to be, Raylene? Anything but the origin is fair game right now. One, 2. Okay. Now, notationally, we want to make sure your book does a pretty good job of using like really specific notation. And you guys may love it. You might hate it. I'm okay with either, to be honest. But we're going to write this out. We are going to dilate this 1 point that could be on a bigger polygon by a factor of 1/2 about this center. So I'm going to put the center on here real quick, and it doesn't have to be perfect. I'm eyeballing it. Here's the center, and I'll just call this center. And it's at the point 1, 2. Okay, if I want to dilate this thing by a factor of 1/2 about this center, the way that we write this is we're going to say that this thing is going to go from A and some ordered pair, which we already know is -6, 7. And it's going to map to its new point on the image called what again? A prime. Love it. Now, let's just make sure that we can get the notation and a little bit more practice. The way that we formally write down what it is that we're doing. What letter do you think we might use for dilation? Like T was transformation, capital R was rotate, lowercase r was reflect. Any guesses for a dilation? D, I think, is a reasonable thought. Your book uses a capital D. If I want you to dilate something, I need to tell you 2 things about it. What are the 2? I need to know the points, obviously. That's just a given. What are the other 2 things we had to have, and I made you guys pick for me? Good. What is our scale factor here? So the way that we write this, and it's with a subscript, so a little submarine underneath, the scale factor is 1/2. And what's that center that we're rotating around? 1, 2. And just for convenience sake, I'm going to call this point C for center, just so I can make this a little bit nicer. About point C. Now, if you wanted to, you could say D, and then it winds up being 1/2, and you don't want to write point C. I suppose it's reasonable to write the ordered pair that we're going around. This one is unnecessarily ugly just by virtue of the fact that they're all 1s and 2s. Okay, so without moving everything, let's try this. And if you want other points, like if you want it to be a triangle or something, I can add some other points, and we don't even care what they are. Lily, was that an affirmative? Did you want other points, or are you okay with just 1 point? Okay, so we can do this nicely. I'm going to simply, if we're doing this on the graph, I'm going to do it here, and I'm going to let this ray go through those points. Now, I know that whatever I'm doing here, I need to go, how much the size? What's my scale factor? Half of it. So to get from my center to A, how far do I go? And I'll make even notes here. Center, C, whoa, way too light. From C to A, we have 2 different directions that we need to go. I'm going to first deal with the horizontal. And how far to get from C to A do we have to go? Too many answers at once. Sorry. Camille, do you know the answer? 7. Good. We move 7. What direction? Left. Now, with a scale factor of 1/2, I'm just going to say, put this here. K equals 1/2. How far to the left do we go then? This implies, what's half of 7? Lily claims 3.5. Anybody second that? I'll second it. Deal. So I go left how far? If we are there, A prime is just simply left 3.5 from center. Now, we have to be very clear, and you don't have to actually write this out every time. Could I have said 3.5 from A instead? In this situation, they're the same number, right? Like, it doesn't matter if I go from A or B. If this was 1/4, I would definitely want to do it very specifically from my center. So here we are. Am I backward on that? Let me think about that. Miss Sweet, did you catch, do I feel backward?
No.
I count from the center.
Yeah.
Okay. Weird. My brain had a weird little hiccup there. So here we are at 1, 2. If I go 3 left, where does 1 become? So 1, we'll go 1 left, we're at 0. 1 more left, we're at -1. 1 more left, we're at -2. And half more. If I'm at -2 and I move 1/2 more to the left, where do I wind up? Negative what?
2.5.
-2.5. Now, there's other ways that we can think about this, and only with 1/2, you might rather use the midpoint, and I'm okay with that. Ashley, it seems like I've lost you somewhere. So if you go, and we'll even do it here, what's 1 minus 3.5? -2.5, right? So I just counted it out rather than just doing the math. Same thing though. So where's my new x coordinate then? Oh, dang it, I already had it. -2.5. How far vertically do we move? Vertically, we move 5 down. Okay, so I'm fine with that. Or 5, how do I want to word this? It'd be 5 up from the center, wouldn't it? From center. And half of that is what? So we move how much up? So 2.5 up. And then we'll do the same thing here. We're just figuring out what is that distance. And if I moved 2.5 up from my center, 2 plus 2.5, where do I end up? Good. Now, my scale is not perfect, but I'm going to eyeball it out. If I go left 2.5, which is like roughly here, and I go up 4.5, which is roughly here, does it look like I have half the distance? Would you believe it's half? Boom. And we can do it. It's the exact same thing we did on the previous problem. I got a weird mental hiccup for a little minute in there. Terribly sorry about it. Feels okay, feels awful. All right, I guess I'm going to say prove it, and let's knock out the assignment. So we're going to have 15 or so minutes. I'm going to try to get a head start on the next section today. We're going to see if it shakes out that way or not. And let's check here, because I am going to ask, because I don't have it. I lied. I do have it. It's right here. I'm going to throw it up for you. All right, for your assignment tonight, I'll put it on the classroom here in just a minute. But I want you guys to have a blast working the following. So your homework this evening is going to be homework 7.1.
Page 312.
Thank you. Homework 7.1, page 312. And I want you guys to do 10 through 20 even. 21, 22, and 26. And then just a language difference. You don't have to write spicy problem here. I want you to put asterisks around number 26. And a quick reminder. Asterisk around number 11. I'm mistaken. My bad. What do the asterisks indicate? We've done it a few times. It presents itself as a more challenging problem. Do not just assume that it is a more challenging problem because it's spicy. Don't let that psych you out. But if you do that problem and you get it right, and if I ask you, like, how did you do it, you can explain to me what you've done, I'll give you a free late homework pass. But you have to be able to explain it to me. So if GPT or Google can do it, don't care. I care if you can do it. Sweet. All right. I'm going to give us like 15 minutes to get started into it. I'm not going to end the video quite yet. I will resume it if we wind up starting the next section. Cool. We'll probably be back momentarily.